All right, in this video, we're going to be working some parametric and polar free response questions that allow the use of a calculator. And this first one is a parametric equation, and it says time limit 15 minutes, but it does have more parts than usual. But I think 15 minutes is actually pretty fair on this one, because parametric is somewhere where we need to be, saving some time. If we know our formulas and we know what we're doing and we have experience with these problems, we should be able to do these in under 15 minutes. So, okay, they're going to give us the position is x of t and y of t, the derivative of x is 8t minus t squared, and the derivative of y is this thing. We're going to need to type these into our calculator. So I'm going to recommend we type these in as f of t equals 8t minus t squared, and g of t equals t to the 1.2 plus 20 plus 0.5 minus t. All right, now we're gonna need these. Are we gonna need speed? Yes, I already see that in part A, so I'm gonna make h of t equal to the square root of f of t squared plus g of t squared. Okay, and then, let's see, is there anything slope? Path is horizontal or vertical. Yeah, I don't know that we'll necessarily need it for that. Okay, so I'm not going to pre-program a slope formula if I don't see, like, find when the slope equals 5 or find what is the slope when t equals 4 or anything like that. All right, so the first one asks for the acceleration of the object and the speed of the object at time t equals 2. Okay, so it asked for acceleration, and we know that acceleration is the first derivative of velocity, but we need to, when we're taking a derivative on the calculator, we need to show that. So I'm going to write down a of 2 is going to equal x double prime of 2 and y double prime of 2, which means I'm taking the derivatives of these functions over here on the calculator. F prime of 2, I didn't put in the prime. Okay, f prime of 2 is equal to 4, so that does make sense, thinking about what x prime was equal to. And then we can just go change that out to a g prime and get negative 0.854. And if we want the speed at time t equals 2, I'm going to show what I'm plugging into the calculator. That would be x prime of 2 squared plus y prime of 2 squared. And that's going to equal just h of 2 is 12.305. Okay, part B, find the total distance traveled by the particle. We know the formula for that. Show the setup for your calculations. That just means, we need to show the things that we already know that we have to show for the calculator. Okay, so total distance on 0 to 10. All right, so we're going to integrate the speed, 0 to 10, square root of x prime of t squared plus y prime of t squared dt. That's just going to be the integral of h of t from 0 up to 10 of h of t dt, and get 109.044. CS for the y-coordinate of the position at time t equals 0. So we'll need to remember the fact that the y-coordinate at time 2 was 6. And if we want to know y of 0, and we don't have the ability to anti-differentiate y prime, which we definitely don't, that kind of composition of function is not something we're going to be able to deal with. That's going to be y of 2, and plus we've got a calculator anyway, so why would you even want to do that? So the integral from 2 back to 0 on y prime of t dt, which they've already defined, so we can just, okay, we're calling that g. So that's 6 plus the integral from 2 to 0 of g of t dt, and get negative 1.174. Okay. D is looking for times when the speed is less than 4. Okay, so I'm gonna need to graph the speed, and that's h of t. I'll zoom out a little bit. And less than 4, okay, I see what we're getting at here. So I'm going to graph y equals 4. And, okay, I should probably store both of those points. All right. Those are going to be the two x values, okay, where y equals 4 and this thing intersect. So those are going to be the t values that I'm looking for. Okay, between those two times, the speed is less than 4. All right, so I'm going to my response area. I'm going to say the equation or the inequality that I'm solving, and that's going to be speed x prime of t squared plus y prime of t squared is less than 4, and that would be t between the 7.536 and t equals 8.360. Okay. All right, now part E, yeah, horizontal or vertical tangent. Now that's, maybe reaching for a lot, but, I just figured, on a practice problem like this, might as well go for all of them. And so we'll do both of them, and we'll just be interested in where x prime equals 0 and where y prime equals 0. Okay, so I'm just going to be considering the times on the interior of the time interval 0 to 10. And so I am going to restrict the domains of f and g to 0 to 10. So 0 less than t less than 10. And I can copy that and paste it there. Turn off all of these graphs and turn those on. And so I'll be interested in like that point and this point right there. Okay, so that's t equals 8 and t equals 5.222. All right. So first I need to kind of like label what's going on here. All right, so my horizontal tangents. That's going to be where y prime of t equals 0, and when x prime of t is not also 0, but we see they're not ever simultaneously 0. And so I prime is g, that's the blue one, right here is 5.222. And then for vertical tangent, that's going to be when x prime of t equals 0 and y prime is not also equal to 0. And, okay, that's when the red one intersects with the x-axis. That's t equals 8. All right, there we go. Okay, so that's the parametric one. All right, now the next one is a polar problem where we've got the graphs of two polar curves, 5 plus 1/2 theta and 6 minus 5 theta cosine theta. All right, I want to find the areas of the yellow and blue regions, finding the location of a horizontal tangent, and we've got a particle motion question. Great, okay, that's quite a bit going on. So first, I'm gonna just kind of like zoom in on this diagram here. We've got a couple of intersection points that there's going to be 3. Yeah, and that's kind of the whole point of me publishing these problems in general, is that I kind of worried that I had not shown you enough about this. And let me just tell you, these are not pi over 2 and 3 pi over 2 and pi over 6. These are going to be, like kind of bad decimal numbers that we're going to need to be able to find using a calculator. And I just don't think I've trained y'all enough on that. Okay, so this is how you're going to do it. If we want the area of the yellow region, right, and we're thinking about adding areas, it's going to be, oh goodness, that's going to have 3 components. I didn't realize that, but again, that's another thing that I feel like we could need to be ready for, and we're going to need to do that here. All right, so we're going to first find intersection points. Type in f of t equals 5 plus 1/2 t, and g of t equals 6 minus 5t cosine t. Okay, we don't need to be viewing those. And now, actually, yeah, we do. We need to find where they're intersecting. And we're watching from, looks like the graph is running about 0 to 3 pi over 2. So let's just like restrict t to that. We're not really ready to look at the polar graph. And plus, we can already look at the polar graph kind of down below. So we'll restrict it there and see, okay, I see these 3 intersection points that I have labeled over there. Okay, so the first one is 0.18467. All right, so I'm going to store that one, store this one, and store the other one. I'm going to name all 3 of these t values. Let's call them A, B, and C. Over here, and this might be a little bit more extreme than anything we would see on a test or on our AP exam, but I think again it's just best to prepare kind of with a time limit and making sure if we can do it within that time limit, then we'll be ready kind of for anything unexpected. Okay, so I've got all of these values plugged in. I found the intersections using the rectangular graphs. Like it's important that we use y and x or f and g and t. So that we're just getting the regular non-polar graph and finding where they intersect, because those will give us the theta values that we need, which generally go as bounds of integration to find an area. Okay, so in fact, I'm going to go over here to this diagram like I had before, and I'm just going to say this is theta equals A, theta equals B, and over here theta equals C, which are kind of their own numbers. And I'll definitely make sure to report those down on the response sheet, but we'll just kind of make use of those. So this is problem 92. And yeah, before I even get started, I'm going to say let A equal 0.18467, B equal 1.54101, and C equal 4.65532. And then I'll be ready to do, okay, A was find the area of the yellow region. All right. So for yellow, I'm going to be integrating on the circle looking thing, which has to be the simpler looking graph. Now, if you're unsure of which one is which, you're going to turn these off and maybe graph them separately, right? So I'm going to say R equals F of theta. And if we zoom out on 0 to 3 pi over 2, great. That looks a lot like the circular one, not the lumpy one. And if I was to change that to G, there we see, okay, yeah, that also looks familiar. Okay, great. So we know that F is the one that kind of looks like a circle. And so back to over here, I'm going to be integrating on the circle from 0 to A. Okay, so from 0 to A, area is 1/2 r squared d theta. And so do we have a name for these? It's 5 plus half theta. Okay. We could give these a name, but I don't think it's going to be worth it. 5 plus half theta squared d theta. What we can't do is report f and g unless we've already defined them like off to the side, kind of like we did with a, b, and c. But we've already kind of defined a lot of variables, so I'm just going to leave it at a, b, and c. And that's just the first little bit. Then we're going to start picking back up at A, and I would assume integrate towards B. Yeah, A to B on the lumpy one. So that's going to be the more interesting equation, which was 6 minus 5 theta cosine theta. And then the last one is going to be from B to, is it all the way around to, no, it's around to pi. B to pi of back to the first one, which was 5 plus half theta. I'll take a little step back, look at my expression, say this looks good. And now we're going to get to the calculator, and that's going to kind of be a lot. All right, so 1/2 integral from 0 to A of 5 plus half theta, that was f of t squared dt plus half of the integral from a up to b of g squared plus from b up to pi of f of t squared dt. And what has happened? I'm missing a dt right here. Okay, great. 74.340. Right, and so that's kind of a lot of area, but also the diagram is pretty zoomed out, right? Yeah, that's like, yeah, blue should be, hundreds of units of area, so it wouldn't be surprising me that yellow was 70 something. All right, now we're gonna find the area of the blue region, which is going to be actually, I think, a lot easier. It's just gonna be an outside minus inside calculation, and yeah, don't let the yellow area mess with your perception. It's really not contributing anything at all. It's going to start over here at theta equals b, and then as we go from the origin to the far edge, we're hitting both curves, so we're subtracting. I'm just going to keep adding along this way as theta goes from b up to c, right? Just like same outside minus inside the whole time. And so that's going to be basically g of t squared minus f of t squared on the calculator. So for part b, I'm going to say 1/2 of the integral from b to c of, let's see, what do we call it? 6 minus 5 theta cosine theta minus 5 plus half theta squared d theta. We'll run that through the calculator. I'm just going to get rid of all of that and say, right, 1/2 of the integral from b to c of g of t squared. We're going to need more parentheses around this. Minus f of t squared dt is going to be 377.307. All right. C asks for where does 5 plus half theta have a horizontal tangent? It really looks like it's going to be at pi over 2, but I think it's going to be just a little bit off from that because, it's not r equals 5. If it was r equals 5, we would know that was a circle and the horizontal tangent would be at pi over 2. But this is going to be a little bit different. It's going to be a slight spiral. So I'm going to say, all right, 5 plus half theta is r. Okay, and if we want a horizontal tangent, that's going to be where dy d theta equals 0. So y is going to equal r sine theta, which is 5 plus half theta sine theta. Okay, now we're going to take the derivative and find where it's equal to 0, but we don't need to take the derivative by hand. We can use the calculator to take the derivative. So I'm going to say, really, now I'm solving the equation dy d theta equals 0. I'm going to go to the calculator and clear out a bunch of stuff. Maybe I'll just go right here. And I'll say y equals, okay. And we can actually even do y equals r sine theta. So that's f of theta sine theta. Yeah, and we can see where its derivative is 0, right? That's what we want, is where the derivative of y with respect to t or theta is equal to 0, and that's clear at this point right here, 1.656. Now what we could also do, I would point out, is that we could also have graphed the derivative of that, so I call that h of t, and then graphed y equals h prime of t and figured out where that went through 0, and that would be at that same 1.656 number. Okay, great. Now for part D, we're interested in, okay, a particle motion situation on the other curve. dr dt is 0.3, what is d theta dt? Show the setup for the calculations, indicate units of measure. Okay, so R is measured in units per minute. All right. And theta is going to be measured in radians per minute. Or d theta dt is going to be measured in radians per minute. Theta is going to be measured in radians always in this class. So dr dt is 0.3. So we've got R equals 6 minus 5 theta cosine theta. And if we want dr dt, I think, we could take the derivative using the product rule and putting in d theta dt every time, but I'm going to point out that it's dr d theta times d theta dt, and we can use the calculator to help us out with that. Okay, I'm going to say dr dt is always that 0.3, they said, and so that's going to be dr d theta at the time we're interested in. So that's like theta equals 3 times the thing that we're looking for to solve eventually d theta dt at theta equals 3. All right, now just like emphasize that. That's what we're looking for. But better than this notation, which is kind of clunky, we could say that this is just r prime of 3. And we've already got this r equals 6 minus 5 theta cosine theta listed in as g of t. So maybe I get rid of all of this and find g prime of 3. And now what I really want is to divide 0.3 by r prime of 3. So I'll say d theta dt is equal to 0.3 divided by r prime of 3, and I can do that. 0.3 divided by, okay, and get 0.042. All right, there we go. And there, even with full explanations and lots of talking and typing and stuff, but still only took 22 minutes. So that's going to be all for this video. Thanks for watching.